Hello and welcome. My name is Omair Javaid, and I am a toolchain tech lead at Lenovo. And this talk is called Mind the Gap. Today we want to check the progress of LLVM Toolchain on Windows and ARM and alert everyone about any gaps, if there are any. So let's get started. So let's start with the good news first. We have native LLVM toolchain on Windows and ARM since LLVM 16. It's working natively. Most of the major components are building and running in the CI as well. The code generation quality, runtime performance is good. The adoption is strong, and at this stage, we are here to finally just close the final gaps and bring it in parity to ARC64 Linux features and also to Windows x64 developer experience. Moving on, let me just go through what's available today. So we have native Clang LLD that produce native ARM64 peak of binaries. And then we also have Clang CL, which gives you the command line compatibility with MSVC, and then ABI compatibility Clang has with MSVC overall. Then we have Flang, the native compiler on Windows and ARM. That's also one of the highlighting feature of LLVM Toolchain. That it's the first Fortran compiler for Windows and ARM. Then we have LLDB debugger, which supports native debugging workflows on Windows and ARM. And OpenMP is enabled. And also we have a version of LLVM, which is part of MinGW tools that provides us with the GNU toolchain support. So GCC toolchain is not yet there yet. So in the MinGW tools, we are currently using LLVM, which is great. How this LLVM managed to become the backbone of Windows and ARM ecosystem. We reuse the ARC64 backend, which is shared across Windows, Linux, Mac OS, and also the code view support or the COF and structure exception handling support. All of that was already implemented for x64, and Windows and ARM had to just do a lot of ABI stuff, but mostly the support was there, and we just had to fix a few things here and there, and we were all set. That shared backend and shared front end meant that we have lots of performance benefits arriving everywhere. And on Windows and ARM, it mattered the most because MSVC toolchain doesn't have certain features which the native LLVM toolchain has. So that's a great advantage we have in that space. Similar to the backend, on the front end side, the shared stuff between the C++ support and Rust, Fortran, MLI, all these languages were able to come in and provide the compilers for Windows and ARM. Some of them are in experimental stage, but like for example, Fortran, Rust, C++, they are ready and available on Windows and ARM platform. So moving on, that's my favorite slide because this is where we show where LLVM is being used in the Windows and ARM ecosystem. So for example, Python, a major project, is using Clang, Blender, LibreOffice. And similarly, Chrome, Edge, Firefox, these teams extensively used the Windows and ARM compiler to provide the Windows ARM64 binaries for these projects. So we at Lenovo have been tracking Windows and ARM ecosystem very closely, and we've put up a website called Works on Windows and ARM that tracks the growing native Windows and ARM app ecosystem. And if you want to check which apps are natively available on that platform, you can refer to that website. So We would like to make it more performant, but as far as LLVM is concerned, it's already beating MSVC. So last year we gave a
or fire exit
we
stairway.
we
Do not use elevators. Repeat, do not use elevators.
yeah.
Attention. An emergency has been reported.
It was a quick break. Let's let's start from where we left. So we were talking about the performance of LLVM on Windows and ARM. So LLVM is great in that way because not only that it outperforms the emulation stuff, which obviously it will, but it also outperforms MSVC in the Spec 2017 benchmarks, as well as various real-world workloads. Like, for example, if you build LLVM with Clang CL versus CL, there's a lot of difference between the build times. And then one of the projects which highlights the performance aspect is Blender, where we saw about 20%, 30%. I'm not allowed to take numbers here, but that's roughly 20-30% of performance boost just because of using Clang CL. So it's great in that way. As far as Flang performance is concerned, we haven't been able to validate that. We haven't been able to run Spec 2017 with Windows and ARM on Flang, but as it's the only Fortran compiler, so nobody has any complaints so far. One thing with regards to developer experience on Windows and ARM, or generally on Windows, is that it's slow compared to Linux, macOS developer experience. LLVM builds are like, if you build LLVM on Windows, it's slow. The NTFS file system overhead or Windows process creation overhead makes it a bit difficult for any projects which have a number of object files to create. Go slow on Windows overall. So we need to find novel ways to fix these issues on these platforms. Like one of the suggestions was to use Clang in a way that it serves as a server and then builds a whole lot of binaries in that using that server. But these are just ideas. We haven't been able to discuss it. So moving on to real gaps, where we have to put our time on. So we have identified the most number of gaps with our debugger, the LLDB debugger. And I have listed like a few of them over here. And some of them might not be known to me or our partners, but if you guys know, you should definitely share any other problems. So starting with LLDB. ARM64EC, it's an ABI developed by Microsoft, which lets you have x64 emulated code and ARC64 code in the same binary, and the code can go back and forth. And so that kind of mixed mode debugging is not supported. Then if a binary is emulated using x64 emulation, then that x64 emulated binary is also not supported by the native LLDB at this stage. Then ARMv9 features. We don't have a laptop, a commercial offering that has ARMv9 Windows on ARM hardware, but we do have cloud hardware, and also QEMU has support for all the ARMv9 features. So we don't have SV, SME register visibility at this stage. And then hardware watch points. So hardware watch points are supported, but you can only set one hardware watch point. That is a Windows limitation that we've reported to Microsoft, and they are trying to fix that. And then there are no hardware breakpoints as well. That we also have limitations from Windows kernel side, and we need to fix that on their end. And then we will implement this on the LLDB side. So LLDB DAP, that is a component of LLDB that lets it talk to the things like VS Code or any other IDEs that want to use LLDB as a debugger. And that has a very flaky experience at best. Maybe there are some downstream patches with the companies which ship the commercial offerings, but as far as the LLDB in upstream LLDB is concerned, I think we've been sort of disabling a lot of tests around LLDB just because they are flaky. And then when we compare features which are available for Linux versus Windows, there are also many features in LLDB DAP which are missing in Windows versus Linux or Mac OS. Then the PDB debug experience. So LLDB has two set of PDB reader plugins. One is the Microsoft PDB reader, and then there is a native PDB reader. So tests show failing using the native PDB reader, but I just before the talk I just saw a PR which fixes all these tests, and so that's when we just had that native PDB reader has no issues anymore that are failing. But overall, the debug experience, like you can do the edit and continue on MSVC, but you can't do that on using LLDB, even with VS Code and everything together. Similarly, the PDB debug info generated by Clang sometimes skips the variables and mark them as optimized when debugging with either LLDB or MSVC debugger. So that's something that the PDB debugging experience we need to heavily test and check on Windows in general, and specifically on Windows on ARM platform. Moving on to other tools. So we have LLD, similar to LLDB. It also doesn't have the linking support for ARM64 EC. That means that you can compile your code for ARM64 EC using Clang, but you cannot actually link it. So for that, you have to use Microsoft Linker. And the reason for that is some information about linking ARM64 EC binaries is not available in the documentation, and that has actually restricted us from implementing the LLD support. I'm not sure. We've been talking to Microsoft to share that information, but I'm not sure if that is going to happen anytime soon. And if there is a need somewhere, then probably, like many other features, this might also have to be one can just figure that out by reverse engineering and fix that. Then talking about LTO, LLD, we haven't actually been able to validate the capability of LLD when you use the link time optimization on Windows and ARM. So if anyone has information on that, maybe share with us. And if there are any missing links, but this is something that has not been tested a lot on this platform. Moving on to Clang. Clang has been instrumental in providing the Fortran compiler on Windows on ARM. However, there are some hiccups. Like, for example, we don't support MSVC style command line driver like we support for CC++ in the shape of Clang CL. That means that in the projects which use Clang, Flang, and MSVC linker, or a mix of these, there is a problem putting in MS putting in Clang into those projects, and there is a lot of fixing involved in the build system to get that working. And this is one of the reasons that we haven't been able to successfully run Spec 2017 benchmarks for Clang all on Windows ARM, but that is not the only reason. Yeah, that's something that is missing, and we need to figure out how to enable that. And iFort has on Windows 64 the command line compatibility with MSVC, and it's Intel Fortran compiler, but it's still based on LLVM, so we should be able to get that working with Clang as well. Then sanitizers, we don't have support for sanitizers. It's unfortunate that we know this for like few years now, but every time we got around starting to fix sanitizers on Windows and ARM, the priorities moved here and there, and at this stage we don't have them in the Windows and ARM native releases, and we want to have them in future releases whenever the support comes in and the fixes are entered into the upstream LLVM project. Okay, so I went through the gaps a little quickly just because of the break that we had. Anyways, for future, we need ARM v9 enablement. I know for sure that there is a whole bunch of ARM v9 enabled hardware coming to Windows platform in near future, like 6, 12, 18 months. There will be more hardware that has ARM v8.3 plus enabled, or ARM v9 features enabled. And LLVM has support for mostly all of these features, apart from LLDB debugger or the ABI stuff that we need to provide to the overall toolchain. However, we have these features working like SME, PAC, MT, BTI, all these features are working for ARM Linux. So we should be good here, but we are still waiting on Windows kernel support for these, and also for the hardware availability. And once that is available, then we will put up CI and test things, and then report issues and fix the remaining pieces of this enablement path. So let's move on to testing and CI and releases stuff. So we at Lenovo have been doing LLVM CI for like last 4 or 5 years. We have 3 bots, rather 4 or 5 build bots running it for Windows and ARM at this stage. One is testing Clang, the other is testing Clang, all the single stage bots. Then there is LLDB bot, and we are testing Clang, OpenMP, compiler RT combination with that. We also have a 2-stage bot, but that is flaky. We run them on Surface Pro tablets, and these are not well suited for that kind of testing. But we hope that we will get a better hardware for these, and then we will migrate them to those. Until then, we will be running these in the staging area. So more recently, we've been trying to make the test suite bots working on Windows and ARM, which we recently did. LNT, which is a component of the testing infrastructure for test suite, LLVM test suite, was enabled for Windows and ARM. We have a staging bot that tests the LLVM test suite with the LNT enabled, and that is running the Clang unit tests, which are part of the LLVM test suite repository. Other than that, there are other tests as well, like G-Fortran tests and single stage, multi-stage, multi-source, single source tests, which are currently not supported, but we plan on working ourselves and with our partners to fix those. Okay. So about the releases, we've been producing LLVM Windows and ARM releases since LLVM 16. And we've been doing that using the upstream LLVM release scripts. We have improved LLVM release scripts as well over the past few years to have it enabled for Windows and ARM. We recently added the PGO based LLVM releases for Windows and ARM. We don't have the performance improvement numbers with that one, but I think as with x64 Windows, that will also have some performance gains. So recently, like a few months ago, like 5 months ago, GitHub Actions was available. The native Windows and ARM runners were available on GitHub, and we plan on migrating the Windows ARM release process to the GitHub Actions soon. And then SVE testing and validation. I don't know how this bullet landed here, but yes, we've been trying to get SVE testing and validation working with Windows and ARM. That's also a resource restriction. We do have the Azure Cloud ARM v9 hardware which supports SVE, but the problem is that we don't have the enough resources to, fund that. So I haven't been able to test whether even SVE testing is going to work in that in that cloud infrastructure. So moving on, one thing that is important to us is the ecosystem growth. And recently, we had GCC enabled for Windows and ARM, which will help the overall toolchain infrastructure on Windows and ARM. It's still in the very early stages. Like it's just a GCC cross compiler. And it does not support the C++ as yet because the structure exception handling patches are still in work in progress. And also, there are still missing gaps in overall toolchain. So it's not native, it's still cross-compiling. But what we've been able to unlock with GCC support is that we've been able to build Git for Windows and similar GNU-dependent applications for Windows and ARM. And also, with this, I think we will be able to run the multi-source or single-source tests and also G4tran tests for Windows and ARM. I'm almost done. I think, yeah. I'm done. Thank you very much. If you guys have any questions at this stage, you are welcome to ask.
Yeah, there's a stand that way, but also the opportunity here. I have a mic. Any questions?
Thanks for the talk. I'm curious on the LLDB side, like what are your order of priorities? Like what would you like to get first? Does it match the order on the slides, or are there any particular subset you want to get to sooner than any other?
I think as far as the interest is, we do have interest in the SVE support the most from our partners, as well as because we have hardware, at least in the cloud, available, and also the QEMU support is there. A lot of people talk about ARM64 EC, but nobody comes up and say, like, we are going to fund that work, and we will be able to provide enough funding to have it working. So that's one thing. Then general, I think, as far as us maintaining the project are concerned, I think we will work towards stabilizing LLDB DApp, overall test suite, the native PDB reader as the maintainers of LLDB project. But for the particular features, I think we are at this stage require funding and interest from external parties to fund us to do these things. Till that time, I think as soon as the hardware becomes available, there will be interest in all the ARM v9 features. That's my understanding.
First half next year.
See?
That's
So,
what was announced.
yeah. So that's an interesting and piece of information that in the next year, first half, you'll have ARM v9 enabled hardware on Windows and ARM. So that's when we get the support starting to develop, or at least we start to work on it. Let's see.
I had a question. How do you prioritize what you want to fix?
So we at this stage, like for example, we as part of Lenovo has a steering committee, and that steering committee has different companies contributing to that committee, and they decide on our priorities. We give them what's missing, like we provided information. And then they also have, like, for example, Qualcomm or ARM or any other companies who might be doing something internally, like releasing new hardware. And for that, they might have some interest in developing certain features, and then they bring that with the resources to the steering committee, and then we start working on that.
Any other questions?
A comment and a question. The comment, I think we built Chrome for Windows ARM64 with LTO, so I think that does work.
Yeah, that's what my understanding is, but I haven't tested that in the CI overall and compared that whether there is real gains there or not. I'm not saying that it doesn't work. It's just that there's not enough information about how much gain you can have with LTO, and also what's the interoperability between the MSVC compiled code with Clang CL compiled code with LTO. Is that supported or not? That I'm not sure about.
And then you said LD-Link cannot link ARM64 EC code. I've seen like a whole bunch of patches by Jacek at Codeweavers. Is that not complete?
Yeah, there were patches, but at one point the information got stalled, which was required to get the final bits in. I am not exactly sure what information was that, but what Microsoft told me is that the PE-COF standard is closed source, so some parts of it cannot be shared with general public. So that is actually blocking the ARM64 EC at this stage.
I would like to thank our speaker.